So, when UNESCO organized the first conference on underwater archaeology in the early 70s, the new branch of archaeological studies was characterized as a nascent discipline. Although important discoveries at sea have been made since the 19th century, most of them were random and incidental. Underwater archaeology went through many stages before finally being integrated into the main body of archaeology as a science governed by clearly defined principles, rules, and ethics. Still, for the most part of the 20th century, the deliberate and systematic recovery of antiquities from the seabed was in the hands of people who did not hold specific academic qualifications. From the concept of salvage, deeply embedded in the public perception, to the concept of scientific research, there was a long way. I think we have technical problems. Diving was not considered compatible with the qualities expected of an academic, and at best, to quote George Bass' phrase, archaeologists stayed on deck and gratefully accepted the artifacts handed up to them by hired divers. The non-involvement of archaeologists and the absence of even a rudimentary methodology resulted many times in the use of destructive methods in underwater digging, with no substantial documentation whatsoever, and serious errors and misunderstandings in the publications of that period. This era of absent directors might have been also an era of good intentions, but good intentions could hardly match the required abilities to understand the full potential of any underwater archaeological site. So underwater archaeology, just like most of other scientific research, was developed through trial and error. As Albert Falcot, chief diver of Jacques Cousteau, stated for the Grand Congolais excavation, our leading diver on Grand Congolais was Frédéric Dumas. We were doing 2 or 3 40-meter dives every day. It was quite something, but I was new to the job. That said, all they told me was, here's your dredge for sucking up the sediment and handle the pottery with care. We brought up 4,000 amphorae and 10,000 pieces of pottery. One day I managed to fill my basket with 36 amphorae in a single dive. It took me only a quarter of an hour. It was a conveyor belt. We don't need to contemplate much in search of any methodology involved in those early efforts, because simply there wasn't any. Even the documentation of archaeological sites in the shallows suffered from the same deficiencies. The Marathon survey, conducted by a French team of divers during the summer of 1950, stands out as a typical example. The site was revisited and systematically investigated by the Southern Euboean Gulf project 60 years later. Although the results of the 1950 survey were published by acknowledged scholars like François Bremer and Jean Marcadet, the BCA's report shows inconsistency with all data collected from the site during the recent years. There was indeed a lot of misunderstanding between the academics who published and the divers who conducted the survey. Serious information about the underwater distribution of the material, the depth and the exact location of wrecks were wrongly conveyed. Since there was no kind of previous experience, the evaluation of the site failed significantly to present a clear and accurate report. This pioneering stage of shipwreck archaeology, controlled by scuba divers, was short-lived. I think almost everyone in this hall will agree that if we are to draw a line in the 20th century, it will be somewhere between the late 50s and the early 60s, when George Bass undertook the excavations of the late Bronze Age Caledonia wreck, and immediately after the excavation of the wreck Yasiada I. George Bass was the first to consistently transfer and apply the methodology and know-how of terrestrial excavations into the sea, and with his work he established new principles and standards for how research should be done. Methodology, as applied by its etymology, refers to how a project is going to be undertaken, which approach will be taken, and which working techniques will be employed. It defines how the identified research question will be answered, and it should be aligned directly with the objectives of the project. Irrespective of the concrete methodology chosen, it will have to meet some minimum conditions if it is to respond effectively to the challenges that work underwater presents. There is no single recipe, and an appropriate practice varies significantly depending on the specific requirements of each individual site. It's needless to say that methodology as a conception runs all aspects of a project, and not only the actual fieldwork. It affects project design, preliminary work, financial planning and funding, timetables, conservation, site management, safety protocols, dissemination of the results, and publication. It should also be noted that methodology, as much as it is considered a theoretical framework within which the research moves, it often incurs a heavy cost as it is directly linked to the personnel involved in the project and the equipment that will be required for its implementation. For the sake of this presentation, I will confine to the aspects of methodology that are directly applicable to the actual fieldwork, and mainly to on-site documentation, because the level of documentation is essentially what distinguishes an archaeological project from the pure salvage of ancient artifacts. For the sake of this presentation, I will also separate underwater archaeological projects in two main categories that are part of the same process but present different challenges, are susceptible to different levels of documentation, and are differentiated from each other from the level of human intervention and intrusiveness, that is, surveys and excavations. I will delve for typical examples into the past, presenting mostly projects from my own experience with a tint of a personal account. Each project sets its objectives, formulates a master plan of desired field actions, selects personnel together with the means, tools, and equipment of the implementation, defines the time and duration of the project, and based on all the above, results in a budget. Project management and funding might entail broad visions and strategies. Open-ended solutions, however, are not an option. Every project must have its beginning and its end, and the specific project objectives should not go beyond what can be overseen and evaluated. Securing adequate funding over a long period of time might prove a utopia. An average time for the completion of the shipwreck excavation in the Mediterranean, especially if conducted in deep waters, can easily exceed the 10-year limit. As a rule, underwater projects tend to last longer than originally planned and expected. Project directors operating in an international context influenced by many external factors do not have guaranteed funding that can be easily repeated over such a long period of time. A director might submit 3 or 4 years' budgets for approval, but usually only has a clear picture of the next field season, and often has to rely on funds that have not yet been dispersed or will be dispersed while the project is already in progress. Bureaucratic procedures, international financial crisis, pandemics, or extreme weather conditions can cause serious delays, and funds might arrive with terms and conditions that make them technically impossible to use. These restrictions create financial risks, tensions, and quite a lot of stress. If funds are not adequate, there are several ways of dealing with it. The option of zero compromise is the most rigid view. If the budget for a research is not fully covered, the project will be postponed for the next field period, when funding conditions will be theoretically or actually better. I have found myself in this position at least 3 times during my career, and large-scale projects had to be cancelled, sometimes in the very last minute. A second school of thinking is much more based on the actual availability of funds. This means that original intentions and objectives should be reconsidered and goals and priorities should be adjusted to the funds that are available. If a project director finds himself in this predicament, which, let me say, around these waters is not unusual at all, there are two obvious solutions to these problems. Either shorten the duration of the field period down or make cuts on the staff. And it is not rare, we will need to do both. I will start commenting on the second one. Research staff reductions mean fewer people will be required to accomplish more, potentially in less time, and that working hours will be extended to the extreme limit. Smaller teams are not always necessarily a disadvantage. Experience has shown that small cohesive work teams at sea can prove to be much more efficient and productive than large multi-person teams that can become difficult to manage. On the contrary, the decrease of the field period to lower down the cost is an option to be considered only in specific cases. Here, of course, it should be noted that archaeological projects show a great diversity on their purposes, approaches, aims, objectives, and organization. Their actual cost, however, is usually defined by distance, exposure to weather conditions of the site, and depth. To give a tangible example, the underwater archaeological project in Furni started as a survey in 2015 with the aim of recording and documenting ancient, medieval, and modern shipwrecks in the Furni archipelago, an island complex located in the eastern Aegean. And currently, the project is excavating a shipwreck of the late Roman period. The duration of its campaign through these years has been determined to 25 days. This means that at least 2 days of the project should be spent on traveling and transportation while setting up infrastructures, anchor and supporting vessel above the shipwreck, assemble airlift, prepare gases, perform trials, set outdoor conservation lab, and complete safety procedures necessitate another 3 days, plus another 2 days for maintaining, packing, and storing everything back at the end of the project. Mobilization, demobilization, and preparatory actions require significant time, which is attributed to the dead, non-productive time of a project. The originally planned 25 days are inevitably reduced to 18 days. Since the excavation is taking place on a wreck that is exposed to the weather, in those remaining 18 days, statistically, 30 to 40% every year is lost due to adverse weather conditions that make diving impossible. Therefore, in the project of the order of 25 days, the actual days of uninterrupted work on the seabed might be less than the half. In such cases, one wonders if cutting extra days from research can be a rational solution, or if the result is worth the effort and the cost. An intermediate solution between cutting staff or days is what I call cost compression. A typical research budget is divided into several categories of expenses. For example, the main expenses of the Furni project include transportation and shipping, accommodation, support vessel charter, food, compensation of personnel, if any, fuels and lubricants, purchase of equipment, service and maintenance of equipment, and others. In these categories, we can distinguish elastic and inelastic costs. The cost of transportation is an inelastic expense, and so is the cost of chartering the support vessel to act as a working and diving platform above the research site. An important but sometimes underestimated component in the organization of field projects is where the team will rest, eat, and sleep, not to mention where archaeological logs, diaries, and so on will be completed. If a budget is to be squeezed, then inevitably human comfort will be the first victim to sacrifice. On a practical level, this means that extra bed will be added to a double room, or that the research partner will be forced to live in a self-organized camp or in boats that in many cases were not originally made to accommodate people. Crowded boats that host all functions of an underwater project might create strong ties and companionship between the members of a team, but they can also generate tension and conflict, especially after the first week. Food is less negotiable in shortcuts. The phrase, an army marches on its stomachs, can equally be applied to archaeological projects. It has to be borne in mind that factors affecting the participants' physical well-being will gradually have an impact in daily performance, and archaeological standards may also suffer in the long term accordingly. Surveys can have different aims and objectives, but they all share in common the process of exploring, locating, and documenting a site or a wider area. They can be applied in well-known areas or in completely archaeologically uncharted waters. The late one was the case of many underwater surveys conducted in Greece during the last 20 years, when the protection of underwater heritage became a national priority in the earnest. During the 21st century, more than 150 shipwrecks were documented in Greek territorial waters and added to the national archives, the result of a long-lasting surveys from the effort of Underwater Antiquities, the Hellenic Institute of Maritime Archaeology, and strategic cooperations conducted with third parts. No matter the different approaches and tools they used, they followed generally the main steps of archaeological research and methodology. In any underwater survey, methodology calls for preparatory actions that form a very essential part of the whole process. Consolidating and the accumulating knowledge of local people, especially scuba divers and fishermen, and accounting information in archives, libraries, historical cartography, aerial topography, toponymy, and data from terrestrial archaeology. This is as crucial as the field work itself, but has usually no serious financial cost to affect the project's budget, no matter how time-consuming it might be. The heavy expenses appear when the fieldwork starts. Scrutinizing by diving an extended area along the source is the most common way to accomplish a survey performed by divers. Underwater archaeology manuals often describe searching patterns of swimming or diving in parallel lines, a methodology directly adopted from the land surveys. Though such searching patterns might be effective in shallow and flat seafloors of internal waters, they are of little help in steep and more complicated underwater terrains like the ones that are most common here in the Aegean. Instead, being a rigid set of rules, methodology needs to submit to the peculiarities of the terrain of each individual site and be flexible enough to offer solutions. It is often said that with proper scientific and technical training, the archaeologist will be able to use the minimum of technical resources needed to obtain the best possible scientific results at the lowest cost. In the real world, however, if a project is underfunded, there is a straight relation between time, cost, and the quality of the result. By that I mean that a project might produce high-quality documentation with low financial cost, but this might prove very time-consuming, or that it might produce high-quality documentation in short time, but this will be very expensive. The third option is to produce results quickly and in an expensive way, but this will affect the quality of the documentation. It goes without saying that it is up to every individual archaeologist to prioritize the main objectives of the project and decide what compromises should be made. If the main objective of a survey is to locate shipwrecks in a certain area, documentation might be very elementary and limited to the absolute important information. Coordinates, depth, type of underwater terrain, description of the site, recognition of the cargo, condition report, and chronology, which are the minimum standards to evaluate a site. High accuracy orthophotomosaics, three-dimensional models, sampling or coring can wait the future for the future and might appreciate it of less importance if the priority is to finish survey lines in a vast, exposed, and archaeologically uncharted area. Accurate measurements and ultimate precision can also wait. Survey is a non-intrusive type of research and offers a second and a third chance. Finishing the survey lines has been the main priority in the Furni from 2015 and for the next 4 years, while proper documentation was limited to the primal stage. When the survey finished and all data was on hand, a full period in 2020 was dedicated to go back to the sites already located and create a more precise mapping and documentation. Surveys, by definition, provide opportunities for the researcher to be more flexible in processing times and methodological protocols. He can choose to follow the evidence, he can stop the research anytime, without any impact in the archaeological field, precisely because the entire approach is based on minimal or zero human intervention. In contrast, an excavation leaves much less room for compromise, as the excavation itself is an intrusive and destructive process that requires the maximum possible degree of continuous and repeatable documentation. Although, again, the methodology can be differentiated according to the specific conditions of each individual site, a typical excavation process at sea includes, in small words, a pre-disturbance documentation, the placement of a grid, the gradual removal of sediments that alternates with photogrammetric documentation at all stages of the excavation, and the retrieval of finds or their in situ protection. The pace and progress of the excavation is directly dependent on the environmental conditions and the depth at which it is carried out. The most time-consuming process is again that of underwater documentation. Take into account again the example of the excavation of the late Roman shipwreck at Furni. It is a coherent wreck with a small dispersion of peripheral finds located in a steeply sloping and partly rocky seabed at depth from 42 to 50 meters and has accumulated around it large deposits of sand. The excavation started from the shallow side of the wreck in the 42-44 meter zone. It's the area you can see here. As on any other excavation under the 40-meter zone, diving logistics are very strict and designate to a great extent the progress and pace of the excavation. I will set here 2 examples directly connected to issues of methodology. The total dive time for each diving couple is set to 48 minutes, 2 minutes for the descent to the wreck, 20 minutes of net bottom work, 26 minutes for the ascent and decompression stops using modified oxygen mixture from 21 meters and pure oxygen at 6 and 3 meters depth. In case of a second dive on the same day, these times are reduced even more. So for every 50 minutes or so of diving, there are 20 minutes of useful work. Theoretically, therefore, the dives can follow each other every 20 minutes, and the artifacts can remain in the airlifts can remain in continuous operation and be handed over from one diver to the next one. However, in reality, this ideal sequence of continuous dives cannot be performed. Methodology requires a basic level of understanding and communication between consecutive dives so that instructions can be given, attention can be drawn, and information can be exchanged. These are basic principles for a controlled excavation. Without a doubt, the best level of communication is achieved in a dry environment. This, however, has a heavy impact on the pace and progress of the excavation by dictating that only 1 dive per hour will take place. In addition, each stage of the excavation requires photographic documentation of the progress, and in regular intervals, photogrammetry should be applied to the entire excavation zone. This in turn requires pausing the excavation and waiting for the mud to settle. The ideal, of course, would be to have the possibility of photogrammetry after each dive, so that every step of the excavation process can be recorded. If these procedures, mandated by the methodology protocols, are to be followed in full, the total excavation time of this shipwreck, already estimated at 10 years by the most modest calculation, may be doubled. Are there any ways to cut a path somehow? In relation to the communication of the divers, a tolerable system of communication instead of coming at the surface is that the information is transmitted underwater, preferable in the 6-meter decompression station. The exchange of notes in shorthand underwater has been shown to work to a satisfactory level between divers who are familiar with the wreck and the specifics of the project. This immediately allows doubling the number of dives within an hour, and there are other ways to speed up the pace of work even more. At the level of photographic and photogrammetric recording, however, the compromises that can be made are much more limited. Excavation is nothing less than a destruction of a repository of information. The high-resolution recording of the successive phases of the excavation is the only tool we have to digitally recreate the wreck's relationship with its environment, a relationship that once disturbed cannot be reversed or restored. I hope that it is understandable that practically it's impossible to document the removal of every grain of sand. It would take ages for the completion of just a single trench, and I hope it is not very egoistic for me to say that as a human being, you go around only once. In the excavation of shipwreck 15, photogrammetry is attempted at the end of each working day if lighting and visibility conditions permit, or at the beginning of the following date. Given the slow pace of excavation anyway, this allows progress to be recorded at a satisfactory level without serious data loss. To conclude, methodology comes with a certain cost. It is up to each individual director to balance the needs of a project and align them with the accepted methodological framework. The biggest challenge for a modern underwater archaeologist is therefore to prioritize research objectives, to remain in compliance with specific safety protocols, and to estimate how the cost of a project can be aligned to the objectives with the smallest possible impact in the quality of the result. As a generation, we are lucky enough to operate in the digital era, and technological advantages in underwater photography and photogrammetric software, together with the fact that this innovative technology has become much more user-friendly and is often offered with a substantial cost reduction, can ease such considerations in the future. Thank you very much.
Thank you very much, Yorgo. Very important aspect in our work. Very challenging, but hopefully we'll discuss all that at the end. I would like to welcome our next speaker, Aoife Daly, to talk about tree rings and dendrochronology.
Thank you. First, I'd just like to say it's absolutely wonderful to be here. It's my first visit to Greece, and I've been doing tourist things for the last 2 days. It's absolutely fantastic. I'm coming kind of from a sort of a different end of things than George, because I don't dive on wreck sites. I am an dendroarchaeologist, I guess is what you call me. I work with post-excavation material, and I think it's a very interesting discussion that George is introducing here about the funding for our archaeology. And in my first slide here, you can see I have several logos at the bottom. I have the logo from the European Research Council, because I have had the privilege of being funded for 5 years to do my research from the European Research Council. And I think in terms of funding, those opportunities that we have to apply for research funding once the excavations have been done on the material that might be in our museums is actually an incredible opportunity, and I've had an enormous privilege to do that. And I'm going to be using some of the case studies in this talk which have come from the funding that I got from the European Research Council. But otherwise, I've kind of had a career that has zigzagged between research projects and commercial post-excavation dendrochronology. So in that context, my identity is my little company, my one-woman company registered in Denmark, where I carry out dendrochronology for archaeologists, yeah, as Susanna mentioned, pretty much, well, a lot of Northern Europe, actually. So, but what I'm going to do in this talk is to try and sort of show you some of the ideas that me studying timber and from shipwrecks, but I've also been studying, obviously, other objects or structures of wood. It all goes into one great big pot of data where we can, I think, get some fairly interesting information out of. So I'm going to start off by talking about the first case study that I want to introduce you to. And this is a fairly famous shipwreck that, famous perhaps because it sank when it had only sailed about 1.5 kilometres. It was built in 1628 in Stockholm, and on its sort of maiden voyage coming out of the Stockholm archipelago with, it was the king's ship, the King Gustav Adolf II had commissioned it to be built. And as it sailed out of Stockholm, it collapsed it capsized and sank. And it was raised again in the 1960s. So this is a ship that has been sitting curated in a museum in Stockholm. It's a very popular visit for tourists. And I had well, so the knowledge of this ship, because it is from 1628, there's a lot of records about the ship being built and the ship capsizing. And in actual fact, there's records of where the timber was bought for the building of the King's ship in Stockholm. So you can see here that some timbers were bought from, so Stockholm of course is up here on the Baltic Sea, and timbers were bought from estates inland from Stockholm and from other Swedish estates on the eastern Swedish coast. But funnily enough, for a region which had many trees, lots of forest, they also purchased planks in Königsberg on the Baltic coast, on the eastern Baltic coast, and they also, in fact, purchased planks from Amsterdam. And when I looked at this in my kind of sense of the world in terms of timber, Amsterdam was not placed in a place of forest abundance. Amsterdam was importing all its wood for building the city itself and for building ships. So why were they buying timbers in Amsterdam, bringing them to Stockholm? So these were kind of the questions that I had, and even though we knew what historically where they were purchasing timber, I had so many questions about where really that timber came from for Vasa. So this was one of the main case studies that I applied for the ERC project. And this a little bit into the technique that I used, because the ship is intact. So it wasn't a case of me taking a saw and cutting timbers or even coring very much. So what I did was I crawled around and looked anywhere where I could find a cross section of the timber in situ. So this is up on one of the gun decks, and this is one of the gun ports. So we're inboard, and you can see here the ceiling planks, the inner hull planks. I can see the cross section of the wood on these sides, and I could do the same for the hull planks on the outer side. And then this sill here, which kind of closed off the gun port, we could take those off. I could see the tree rings on this end here, but I could also then see the tree rings on the framing timbers that were exposed there. So I crawled around Vasa for about a year, trying to see tree rings anywhere where I could get a hold of them. And then I took these very close-up photographs. So this is how the oak looks. when you look at the cross section close up. So these are the rings here. Each of these is a new ring. So I was marking every 10th ring, and then I was measuring quite literally on the computer screen to be able to get the actual measurements of the whole sequence. And that would come up with a big long line of numbers like that. And then when I had measured a lot of samples, this is when the going is really good, when we have proper financing for it. I could actually analyse something like 202 timbers from the ship. And what I could clearly see by comparing the different tree ring series with each other was that there were very distinct groups in the material. So I could divide the material up, and I've just used colours there, the blue and the green and the different groups. When I tried to see obviously the date, we already know what the date is of the ship because we have that historical records, but as you can see, this is when the actual sinking took place, but this is the series, the tree ring series that the tree's growth are represented. And so then when I have made these different groups, and I make an average for each group, and then I can test that position, the dated position, against a whole bunch of data sets for Northern Europe for oak. And so you can see that in this case I've mapped how well each group fits with different data sets. And you can see that I've got a date here, but I have not that high correlation. And so if you think back to the first slide there where the timber was purchased, I know that there was timber purchased in the region around Stockholm. So I don't have much data otherwise, because for the built environment in Scandinavia, in Sweden, there was so much pine, and the pine was being used for the terrestrial buildings. So I don't have very much data for oak for that eastern region of Stockholm or eastern region of Sweden. But I'm able to date it from further distance. So I'm thinking maybe this group is one of the groups that belongs to the Eastern Swedish. And the same with the second group, that I'm getting some correlations with Western Sweden, but maybe this is also one of the groups that comes from the Eastern Swedish source. The third group, on the other hand, matched really, really well with Western Sweden, and this was kind of a surprise to me, because there was no record in the historical purchase records of timber having been bought in Western Sweden. So it's very possible that this actually represents the timber that was bought in Amsterdam, that maybe timber was being shipped from the Western Swedish area to Amsterdam. Maybe in Amsterdam they were getting cut into planks, and then at some point some of these timbers were actually shipped back up to Stockholm. So, and then as expected, that we also could see that there are some timbers coming from the Baltic states, a sort of Königsberg region. So well, some of it fits, but some of it is kind of puzzling. And of course I can look to where in the ship the timbers were coming from. So I can actually sort of start to see that this Western Swedish group, for example, seems to be mostly in the top parts of the ship. So perhaps they represent a later supply of timber coming for the building of Vasa. The purchases, actually, the ship sinks, the ship is completed and sank in 1628, but the timber purchasing already started in 1625. So there's been a lot of timber that needed to be gathered for this ship. So that was just kind of a little taster of the kind of case studies that I have been doing. I'm just going to say it might be useful just to go into some of the basics of dendrochronology. The data set is basically built of a whole bunch of trees. We start with modern trees, where we take samples. We know exactly which year we've taken the sample, and then we measure the tree rings back inside the tree, and it's wide and narrow rings. So depending on the climate, the tree is going to have made a narrow ring or a wide ring or something in between. So we can see that there's a pattern. So it's like a kind of fingerprint of the tree. And if we then work further back in time, we work with timbers from buildings, from ancient churches, and from archaeology. And we take samples, we measure the rings, and eventually eventually everything will sort of overlap with each other, and we end up building this big, long sequence of how the trees were reacting to climate. And that is our basic tool for dating something of unknown age. And the sort of basic system then when I analyse a ship or any other building or any other structure, first I take as many samples as there's a budget for, or that looks reasonable, or that have potential, and measure those tree rings and see where they fit with each other first. And then I can make an average of those ones that are fitting. So that's kind of the red one there, which is the average representing this ship. In this case, it's another Danish case study. And then I check for every year if I have a match between my ship and these different chronologies. And then there should be only one place that it fits. And it's not because it fits one chronology. I have to find that same position with different independent chronologies to be absolutely sure that I have the right position. So it's not enough just to date something against a single chronology. And in this case, this ship matched extremely well with a chronology for Denmark. And the outermost ring was formed in 1188. So we have an annual precision in our dating, which is pretty unprecedented in scientific dating techniques. And logically, because the pattern of the variation in the trees is determined by the climate in the region where the tree has been growing. So logically, a tree is going to be most similar to other trees from its region. So that's where the technique of finding the provenance, to finding out the origin of the wood, comes in. So I can, once I have found the position for the ship, I can then say, okay, that's its position. How well does it match all the data that I've got? And in this case, I usually plot it on a map. So when you get these really big clusters of high T values, which are sort of geographically clustered, then you're pretty sure that you're narrowing in on the place where the trees grew for building of that ship. So in this case, it's a 12th century ship. So what I've been doing with the material that I have had my hands on over many years of my research, both in the commercial and the research sphere, I've been making a kind of a timeline. So basically each piece of text there is a ship that most of them I've analysed myself, or else it's data that have been shared with colleagues who've analysed other ships. So you can see I've got this big long timeline. I've been working mostly in the medieval to modern period. So that was the kind of timeline I chose for my ERC project from 1100 to 1700. And so you can see Vasa here at the very end is kind of where my story kind of stops. And then the other example I've shown you is the Colling cog, which is from the 11th century. And I kind of try to use some individual case studies just to sort of fill up the gap between the Colling cog, where I see this a ship that's built really of local wood and very homogeneous, and kind of represents a time where the shipbuilder came to the place where the trees were to build a ship. And then as we come through the centuries, we start to see more and more that timber is transported to different places where ships are being built. So we're going to jump. Yeah, so, and in this case, I've kind of more or less, this is kind of spelling it out, I guess, that from around 1350s, that's when I start to see really the introduction of Baltic oak being brought into Western Europe. And then from around the 1500s, we start to see a much more extensive transport of bulk timber around Northern Europe. And I think the difference in this case is that when we start to see the Baltic timber coming in, we mostly see planks, wainscots, boards, these kind of timbers that are reduced. So they're not transporting big bulky trees. They're transporting sort of, they reduce it into a manageable size, and then they can flat pack it effectively on a ship and send it westwards. So let's just look at the Bremen ship, because what I wanted, so one of the things that's I'm just going to hop across that one. let's talk about the Bremen ship. So this is actually archaeologically identified as the same kind of ship as the Culling. It's called a cog, or the Bremen type is what it's called. And it has been sort of lauded as the ship that the Hanseatic merchants were building and sailing. And you can see the size of the ship, because that's little me sitting inside the ship there, and I sampled it with Mike Balasas 5 or 6 years ago now. And this is, again, it's a ship that's already in clean and dry and conserved in a museum. And I think one of the reasons why, not only because I'm really interested in maritime archaeology, but one of the reasons why ship archaeology tends to be a lot of what I have my research projects on, is because these are the things that are preserved, whereas other archaeological wood doesn't necessarily get conserved. It kind of gets, not conserved. I, with Mike Balasas, analysed the Bremen ship a few years ago. It had been analysed just with 3 samples back when it was already excavated in the 1950s, 1960s, with just 2 samples, and clearly that wasn't enough, and we wanted to really, not so much to find out what the date of the ship was, but to look into the provenance of the timber. And I found, after, I can't remember, sampled 80 samples, 80 timbers, I found that the 2 groups that I could identify, they're pretty much clearly local wood. So the ship was found in Bremen, it's now housed in the German Maritime Museum in Bremen. Yeah, so let's just go back to my timeline. So one of the questions about why we start to see this growth in the trade of timber was to see if it was actually, if we could sort of say that it was due to shortage, or whether it was economy, whether it was just that the Baltic wood that started coming in was just cheaper. But I think we do start to see in some of the regions where economies were really growing at this point, that there was starting, the landscape was becoming more open, and you can see that in the quality of the trees that they were using to build ships. So I'm going to just jump maybe 150 years further forward, because this is a ship that was found in 2018 in Denmark, and this, talking in terms of economy for archaeology and for maritime archaeology, this was a commercial excavation. This was they're building the sort of apartments on the coastline there in Køge in Denmark, and there were several shipwrecks actually found. This kind of is the most interesting one, archaeologically, it is probably a Dutch-built vessel. It has some features which are actually belong in a very short window of some of the features that we see on Dutch vessels, namely that the joining of the clinker planks uses an alternating combination of wooden dowels and metal nails, which is a very particularly Dutch technique that we see actually only in around sort of 3 or 4 decades. And another nice detail was that there was a Portuguese coin found on the vessel as well. So where the find is in Denmark, it's probably a Dutch-built vessel, but the Portuguese coin kind of reminds us that the low countries, the sort of Netherlands, Belgium, was kind of a sort of transport hub, a connection between Northern Europe and the Iberian Peninsula. It was a commercial task, and I analysed something like 80, 90 samples or whatever it was. And in this case, very, very clearly, I could see 2 really distinct groups in the material. The framing timbers were all exclusively belonging to one group, and all the planking exclusively was belonging to another group. Very strong, clear signal there. But what you also notice about the framing timbers in this diagram is that the trees for the framing timbers were much younger. So they're only around 80 to 100-year-old trees that were used for the frames, whereas the other group there, all the planking, were really long-lived trees, some of them maybe 300 years old. And so when I look at the provenance of these different groups, you can see very clearly that the framing timbers are coming from the Low Country or the Lower Saxony, that kind of maybe sort of the Rhine region there. And these are the younger trees that are coming from that area, whereas the planking are all exclusively coming from the Baltic region. So you got a very, very clear distinction between the sources of timbers for the different functions in this ship, a ship that would have been built somewhere in Netherlands. Of course, we also have to think about other things that are coming from the Baltics. For example, artworks, and this is because the Baltic timber trade, it's not just for shipwrecks. It is over something like 3 centuries. There was these planking and these sort of converted trees coming from the Baltics being brought to the West to make also ecclesiastical works and artworks, and we also see this Baltic material on as oak panels on which paintings have been made. So this this is from the same sort of era as this wreck from Kur. It is an altarpiece from Ringsaker Church up in Norway. It was commissioned in the 1520s from a workshop in Antwerp, and all around on this altarpiece, on the sculptures, you see this little hand stamped into the work, and this was the stamp of the Guild of Antwerp. So we know that this timber that was used we know that the work was made in Antwerp, and from the dendrochronology I was able to show that it also was coming from the Baltic region, and this of course built in Antwerp and then transported, of course it must have been by ship, to a church up in Norway. So it kind of links the different timber objects that we can work with the dendrochronology. Yes, I just go back to my timeline there. So I'm just going to jump now to the same era as the Vasa ship, but this time we're going to go to Ireland, a ship that was found in about 10 years ago in Cork, or off the coast of Cork. And this, I was asked to work with the wood on it to do the dendrochronology, but this was kind of really outside my comfort zone, because when I looked at the timbers from the actual ship structure itself, I actually hadn't encountered these timbers before, and made a plan for, because they looked so exotic to me, that what I did was I sampled some of the timbers and looked to see which timbers were the same, and then I took a sample of each and sent it to Peter Gasson in Botanic Gardens in Kew, who knows all about all the exotic woods and is a much better person at identifying woods than I am. And he identified the oak framing as probably cork oak or some of the evergreen oak. So this is the kind of oak I nearly never see in Northern Europe, but is of course in the Mediterranean and in France or whatever. And so a lot of the framing timbers were made of that. And then there were these other sort of pine species that are probably from sort of Mediterranean. The cargo on the wreck included coconuts, so it ended up being called the coconut wreck. It also had Iberian ceramics on board, so we knew also with the exotic timber that this was something coming from further south. On board, though, included in the cargo were barrels, staves and sort of barrel heads. And here I was actually back in my comfort zone, because these were oak, I could totally recognise them. And so I sampled those for dendrochronology and found actually that they were dating with sort of Northern European references. So you can see however, the many samples that were dated, and it meant that we could get some kind of indication of the age of the ship. So we're in around the 1620s, so a little bit the same time as the Vasa. You can see that some of the barrels were made from this Baltic wood. Some of them were made from northern German wood, and some of them are matching with Western Sweden. So we have a sort of funny mix of different Northern European barrels and whatever they might have contained. The last thing that was in the cargo were these very, very enormous wooden chests. So some of them like as big as kind of like almost like a coffin. And these were again some very exotic material that I wasn't familiar with. So again, I took I looked at which ones were the same and then took samples to send to Peter Gasson in Kew. And he was able to identify that some of these timbers were from the laurel family, some of them were from sort of trees like the acacia, these kind of legume trees like we see out there, the acacia. And then there was one single, very thin board, which he was able to identify to genus level. And this was because he had actually an example of this also in their collections in Kew. And this was what they call garlic wood, which actually has a neotropics and temperate Brazil natural distribution. So we had just one piece of wood that gave us an indication for the Americas, the South Americas. So we have coconuts, we have a ship found in Cork with barrels from Northern Europe, ceramics from Iberia, coconuts presumably from the Caribbean, and wood from Brazil. And these chests, when one of the chests, they had this incredible sort of locking mechanism, and one of the chests, when they brought it up, was still locked. And when they opened it, wondering what are we going to find in this chest, it was completely empty. There was nothing in it. But if this chest had come from, this exotic wood had come from Brazil, what is it that was being harvested, cultivated and made? It was sugar. And the sugar that the Portuguese were manufacturing in Brazil, they would make the sugar syrup from the cane, and then they would make these sugar loaf in ceramic, and then presumably they took the ceramic away and packed these cases with the actual water-soluble sugar. So of course, when the case has been under the sea for 500 years or 400 years, all that sugar is dissolved away, and we only have an empty chest. But I think it's also very interesting to sort of see the contrast between the manufacturing of the sugar in Brazil and its appearance in fine art in the Netherlands in this case. That sort of, don't have the one without the other. This ship was, of course, had Iberian ceramics in it, so we don't only have to think of the Netherlands in terms of sugar. This is a painting from the late 17th century, which is actually entitled Sugar Crates Being Weighed at Lisbon. And you can see down here, you see all these sugar crates, and you can see that they are also kind of coffin size, which is exactly the sort of size that we're seeing on this wreck from Cork. So I've probably gone over my time now, have I? No, you haven't been counting. That's good. I'm nearly finished. So I've tried to sort of just choose some sort of very quick sort of case studies to show you the potential and what it is my view of the world, let's say, in terms of nautical archaeology and the timber that was needed for building ships in Northern Europe, and the kind of variation that we can see just by studying scientifically the wood. And so this is something that I'm going to try and sort of build into some sort of narrative eventually when I finally manage to sit down and get it all published. And I've been trying to sort of divide up that era in terms of what I see in terms of this timber supply. So this is kind of, this is a total work in progress, but I'm kind of trying to give my sense of it a structure so that I will somehow be able to create a narrative that brings us through time for ships in Northern Europe. Thanks.
I would like to start the discussion by a short comment by Christos.
Thank you very much for your invitation in this friendly and very warm atmosphere always at the Danish Institute. And I have to thank also the speakers. Less of this, we can start a conversation with the second speaker, Aoife. And well, I would like to thank you very much because you gave us this view from the north. We are not very familiar with this, and you drove me back to my years in the University of Oxford with my professor Sean McGrail and Jonathan Adams at that time. And you reminded us how many valuable information we can get out from these methods of dating and analyzing of the wood itself concerning shipbuilding, seafaring, and the trade of raw materials and other commodities. I wonder, I saw also that this is quite time consuming because we spent a lot of years. Could you give us an idea about, about how much time it is required for, to get some substantial results out of wreck timber?
Yeah.
And furthermore, are there any other laboratory analysis involved? And how much all this package costs? So that I can relate for the sake of
putting a price on it, I think, is maybe the hardest part, actually. But I think we have to remember that, I haven't done this alone, and dendrochronology started really in Europe in the 1960s, 70s, when it really took off. And so a lot of those maps that I show where I've got all those bubbles, that is building on the data that other scientists built over many, many years. So the last half century is represented in a lot of that data. But once we get to a single ship, it is very much reliant on the budget, how much we get to do. But it's also a case of sort of looking at the actual material and seeing how much has potential, because we need trees that are quite long-lived as well. And if, so how long would it take? If I'm doing an analysis of, say, one ship and I get to do 10 samples, that might represent a week or two of lab work and report writing and taking samples and all that. So, but the analysis of Vasa took me pretty much a year, but that was also a very special method, because I was doing it in situ rather than being able to take a chainsaw to it and take samples home to the lab and stuff. So that's, so. And then what was the other question?
Concerning the laboratory, any other laboratory analysis?
Yes. So tree ring width. So a basic analog measurement of how wide the ring is. This is still actually the best method for doing dating and for provenance analysis. But we have been kind of exploring all sorts of, many other researchers as well have been exploring other techniques. For example, isotopes for identifying provenance, that's one of them. So we've been using strontium isotopes. And there are some researchers, particularly a guy called Neil Loader in Swansea, who was working with oxygen isotopes. And this is every single ring, he's measuring the isotopes of oxygen for every single ring and making a whole sequence for oxygen, because this is also being proven to be a really useful dating tool as well. Yes, there are some other new techniques. There's a thing called blue intensity, which the people working with using tree rings for climate reconstruction have been using blue intensity, and in terms of doing that on archaeological wood, we're still sort of in the nursery on that, actually making new experiments with how that's going to work for archaeology. So,
And about the cost?
the cost. So when I applied for the ERC grant, that was 1.5 million euro for 5 years, and that was to work with different case studies and to have postdocs who would work on different techniques. So I had somebody doing strontium isotopes, somebody doing DNA of wood, and I had a historian and an archaeologist also in that team. So that's when the going's really good. That's when you can really play. But when if it's a commercial, yeah, I don't know, what's the cost? I think of it in Danish kroner. You could sort of quote a per sample rate usually. Yeah. So.
And this was a 5-year project, you said, funded by the European Commission.
Yeah.
Okay. So it is an ongoing.
No, it's
ended.
It's ended financially. And we have published a whole bunch of different papers in it, but I still need to write. So that timeline that I showed there, that's kind of the structure that I'm going to do for when I eventually manage them. So, every research project sort of melts into the next, phase. There's never really a cut-off point, I guess.
I must say that you are very lucky to have in your disposal so many wood remains.
Yeah.
Actually,
yes.
Because now, if we want to move in the Mediterranean and in the Aegean in particular, as you know, there are very limited remains. Wood remains, and they are very poorly preserved. I made, a short list here. I was trying to find out through the bibliography where, and if and where this method of dendrochronology is applied in the shipwrecks in the Aegean, and I didn't find them. And in this short list, I found only a dozen of shipwrecks that they preserve wood remains from the hull, and the most of them in very poor condition. They are only small pieces of wood, and those who are preserving larger pieces of wood from the hull that could give us some results after the application of the method of dendrochronology are very few. And usually these are located in flat and sandy bottom or muddy bottom, where the environmental conditions are favorable for the wood's preservation. Otherwise, you know very well, most of us that we are working in the Mediterranean and the Aegean, we know very well that in the archipelagos, like the Aegean or the Ionian, they are very rich in nautical hazards, but the shipwrecks usually happen very close to the shore. The morphology of the shores in the Aegean Islands are very steep, rocky, and they do not offer the conditions for to preserve woods. After all these years that we are working in the underwater projects, personally, I never found wood remains from the hull.
Yeah.
Especially when we're talking about the Bronze Age, and in ships that are crashed on rocky shores, and the cargo was, scattered in the rocky bottom and stayed in small shelves with sandy patches. They are very unfavorable conditions. So in this case, I wanted to ask you, what could we do instead of, because also we don't have a database for, because I saw in your presentation you have a very rich database, especially concerning oak timbers. What other methods could we use here, these small pieces of wood, to get as much as information we can from wood remains, small wood remains?
Yeah, it's tricky. I mean, obviously there's radiocarbon dating, which doesn't, and especially with material, when you're working with prehistoric material, you are going to get good indications of where you are in time with radiocarbon. And if you have enough tree rings in timber, you can make a wiggle match. So you can take samples from some of the rings, and you know exactly the distance between each sample because you can count the rings between, and then you can use the combination of those two pieces of information to actually find a more precise. Should we go into how radiocarbon works? Like, so you have the calibration curve,
yes,
and which reflects the variation of radiocarbon in the atmosphere, which isn't constant. And so when you make a radiocarbon date, you need to calibrate it against this calibration curve, so that you can find how it fits in terms of calendar dates. But if you take samples with known distance between them and measure the carbon in those, then you'll get a little wiggle of those samples you've taken, and then that little wiggle, you'll be able to match it more precisely against that calibration curve. So that's one thing you could do if it was crucial to get a more narrow dating of your timber. But I think archaeology anyway is it's an ephemeral remains that we have. There's always going to be something missing. So I don't think we should dwell on we don't have enough timber, so we can't do dendro, because you have all the amphorae, or you have all the vines and whatever. So archaeology is always going to be a sort of competition with what's missing and what we can use. So, using strontium in terms of identifying provenance, we found that we couldn't actually use it for archaeological wood because the strontium is water soluble. And generally, when you measure strontium from wood that's been underwater or in the ground, you're actually measuring the contamination rather than the wood's original strontium. So when we had success with strontium, it was the wood from standing buildings that we were able to use as a provenance indicator. But then we had the dendrochronology links the standing building timbers with the archaeological timbers, and that way I was been able to identify Swedish timber in Denmark and really identify which timbers are the Swedish timbers and stuff. So unfortunately the strontium isn't really useful for the archaeological wood, but the oxygen isotope stuff might be. But then it is again a case of whether you have enough timber preserved, if you have enough rings in the timber that you can get good long sequences.
Thank you. And well, I would like to ask also George, because as far as I am aware, he was excavating in the harbor of Rhodes a couple of late Byzantine shipwrecks that they were preserved quite well. I mean, the hull was preserved quite well, in muddy bottom, flat muddy bottom again. Whether you applied any methods of analysis concerning the wood remains.
We have a good idea what the wood remains. I don't record the species right now, but it's in small words. It's I think it's the Pinus brutia, which is the Aegean Pine here. This actually was a shipwreck of the Komnenian period, let's say in the middle of the 12th century AD. So a bit earlier than the examples you showed us, but it was a rescue excavation. We had just funds to operate in 5 days. And basically we were mostly interested in the ship's structure and architecture. We took some samples, we did radiocarbon. It agreed pretty much with all the material we found in the wreck. And then we had to abandon the place because it was inside the main port of Rhodes, the island of Rhodes. So we did what we did, we protected, and we reburied much of the shipwreck, all of the shipwreck again, but what happened afterwards, it's very difficult to work inside harbors that are functioning and that are connected with huge economic interests.
Yeah.
This is a great compromise.
This is a great compromise. You can't really stop marine traffic in an island like Rhodes, who's living on the tourism. You can't say to a huge ship with 3,000 passengers that comes, twice a day there, I'm closing the harbor.
Yeah. Yes.
Yeah. So there's compromises everywhere. Yeah.
Yes, in this way you added another category in our, section of work. You said that we have the systematic excavation, the survey, and now the rescue excavation, which obeys some other different rules and have some more strict compromises in terms of time, cost, etc. But you used a lot of times these words, and these words are always in my mind. Compromise, balance, prioritize, and actually these are, I think, the key words for the management of an underwater research projects, and the management of human resources, of financial resources, and how actually you can adapt your research objectives to the actual time and budget. So as I was listening to George's presentation, I was trying to find the areas of compromise in this systematic excavations. I couldn't. As you said very well, there are more space for compromises in the survey underwater, in the areas where you can interrupt the project or you can control the time.
You can come back again.
Anytime.
Excavation, you can't do it. You excavate only once. So
yes.
Yeah.
So there is, during excavation, there is very limited space for compromise, especially in the aspect of time and duration. And, I was thinking of, an area where you could make actually a compromise, always keeping a balance, as you said, is managing the human resources. Where nowadays underwater archaeology is a highly specialized profession, and this profession has to be compensated also. But on the other hand, we cannot compensate the whole team. So what we do, we can use also some volunteers in the team. so we can make a mixture between professionals and volunteers in order to better achieve our scientific objectives. Because always we need to get, as you said, the best result out of the people in the team. But you always have to keep this balance between professionals and volunteers. For instance, how do you manage the students in your students? It's a considerable, human resource. We can have, many benefits out of, people that they are working for the first time. They want to gain experience, and benefits can be in both ways.
Yeah, this is another aspect of underwater archaeology, because the progress of the research itself might not be, the only thing a director has in mind. Especially, I'm teaching in the university, and in every project that I'm doing for the last 2-3 years, I have the students who want to study archaeology and have it's a different thing, to hear it in a classroom and face it in the reality and be on the field. This is, I will have to say, this is another compromise again, because you have to be there, you have to be very, very conscious of every safety matters, because most of the times they are not experienced divers. A lot of times they just finish, the first degree in diving, they have no experience at all. So you have to spend time on them, you have to explain things, you have to keep an eye on them. And in a way, this might keep the pace, the rhythm of the excavation back. Because we dive almost 2 persons a dive. So if the couple is one experienced old professional diver with a youngster, so probably half of the time of the professional experienced person will be just to keep an eye on the youngster that is working next to him. So productivity will drops down. But on the other hand, this is another important aspect of what we're doing, that we have, also to give standards and teach the new generation discipline. Exactly as happened to us for 30 years. We actually with Christos were in the same shipwrecks when we were in our 20s, and we learned in a parallel way together. Again, from people who were patient enough, to give us attention. And
do you also work with sports divers? Do you also work with sport divers?
Sport divers?
Yeah, sort of divers who are not archaeologists.
Yeah, some of them are volunteers. Usually, they might be not archaeologists. First of all, let me say that it's a mixed team. It's not only archaeologists. We have architects, we have conservators of antiquities, we have mechanics, there are many different...
Architects, geologists,
all in the team.
Yeah, in the team. And professional divers.
And professional divers, commercial divers, because they are much more capable of executing more technical matters.
But they are specialized in a way in underwater excavation, because they are working with us for many years, so they are knowing